Adding a pentagonal lamina of 25 mm edges, which is resting on HP on one of its corners, such that the edge opposite to the resting corner is 20 above HP and is inclined at 45 to VP. In this question, the true inclination of the plane with HP is not provided, it is to be determined. And because a corner of the plane is in HP, in the first projection, we'll assume that the entire plane is in HP, and in this way, we'll be able to see the true shape of the plane in top view. And we'll draw the plane in such a way that the corner is positioned to the left side of the figure. So let's say this is the required pentagon. Let's take its projectors into the front view. Like this. Now we can name the points A, B, C, D, and E. The corresponding points in the front view will be A dash, B dash, comma E dash, superimposing, and C dash, comma D dash, also superimposing. This is the front view length. Now, the question says that the edge opposite to the resting corner is 20 above HP. Which is the edge opposite to the resting corner? The edge opposite to the resting corner, when we incline it, suppose when we incline it at any inclination, then A dash point here, A dash point will come over here, and it will be the corner on which the entire plane will be resting on HP. So resting corner is going to be A dash, so the corner opposite to the resting corner will be this side, CD. Now this inclination angle is not given, but we know when A dash will come here, then C dash D dash will come somewhere over here. Because this inclination is not given, we cannot draw this line as of now, but we have been given where this resting corner will be above HP. So its position above HP is already provided to us. So what can we do? We can draw a line 20 above HP. So we can take 20 distance above HP and draw a line parallel to XY. Let's say this is that line. And on this line, we can now take front view length in our compass, take some point over here, and this point as center on XY, taking front view length as radius, cut an arc on this locus. Let's say it cuts somewhere over here, and we can join this with a straight line like this. So what we have done actually is that we have taken this front view length as our radius. From this point as center, we have cut an arc over this locus, and we now know that this point here will be C1 dash comma D1 dash. That means this is the edge which is opposite to the corner on HP, which is now 20 mm above HP. Similarly, this point here will be A1 dash, and we have to take this distance in the compass as well, A to B, and we can cut it here, and wherever that cuts, it will be our points B1 dash and E1 dash. B1 dash, E1 dash. Fine. Now we can take these projectors down into the top view. Simultaneously, we have also obtained the true inclination of the plane that is being made with the HP. Where is that true inclination? We can measure this inclination, and this is the theta which is being asked for. Okay, now let's go back to our projections from the previous top view. Take horizontal projectors like this so that we can complete the second top view. Okay, it's a little bit magnified so that you can see clearly the whole situation. Now we can join the points as we have been doing. So this is A to B to C, D, E, and back to A. We can name the points as well. This is A1, this is B1. Okay, this font is too big. Let's reduce it a bit. Yeah, now let's give it a try once again. A1, yeah, this is okay. So B1, C1, D1, and E1. Okay, now let's go back to the question. Now it says the resting corner, the edge opposite to the resting corner is inclined at 45 degrees to VP. So which is that edge? That edge is this one, CD. A is the resting corner resting on HP. The edge opposite to the top view we can see CD. It is inclined at 45 degrees to VP. Because this edge is showing its true length here, directly continuing from the previous top view, we can take the true inclination of 45 degrees to VP. So let's draw a line 45 degrees to VP and mark it as 45 degrees. Now we have to draw this grid. Okay, we have to draw this grid, this rectangular grid which is enclosing our second top view over here in such a way that this edge is inclined at 45 degrees to VP. Okay, so let's go ahead and do that. Let's say this is the width and this is the length. This is the width again. Just it's not parallel, I guess. Let's give it a try. Yeah, so this I think is perpendicular, this and this one. Now we can take a line passing through the center. Yeah, another line here, a line here, and a line from the center. Not quite the center. Let's try once again. Yeah, let's say that it does it. Now we can draw our pentagon top view by joining the points. So this will be A, B, C, D, E, and back to A. I think I made it a little bigger. It has to be a little smaller, but no issues. Let's go ahead and name the points. A2, B2, C2, D2, and E2. Okay, now we can take up the projectors of these lines into the front view. This is of the point E, this is point A, this is D, this is a projector from point B, and this one from C. Yep, so many projectors. This line we can continue from CD. We can also take projectors from points B and E parallel to XY. Now we can draw our pentagon once again after locating the points. A will be here, followed by B here. C will be here. D is here. E is again downstairs. Where is the projector? Yeah, it is here. And back to A. It will be like this. We can take the points now. So this is A2 dash, and this is B2 dash. This is C2 dash. This is D2 dash, and this one is E2 dash. This completes the question. You can see the entire question now solved. Thank you very much.